Hello friends, good morning. This is Siddharth Verma and welcome back to my channel. So we are going to discuss on the parametric and non-parametric tests. So basically first let me tell you the differences between both the tests. So parametric test is a test in which we have the information about population or we can make assumptions about the population. So those data or those tests for which we can assume the hypothesis, we can make assumptions are parametric, and for those for whom we cannot make assumptions, we cannot assume the population, then those are non-parametric tests. So there are various types of parametric and non-parametric tests. Definitely we will discuss on that. Here I have the table for that, so I will discuss this. Before that, let me tell you that how we identify that a data is parametric, the analysis of the data will be parametric, I mean compare means, or non-parametric. How will we recognize that which test we need to perform, parametric or non-parametric? So here is the very simple way, the most simplest way I figured out, that let's first create a data set. So let's say a data is of age, gender, and salary. Okay. So first of all, let me change the data type. Gender is definitely a string, and we don't want decimals, so decimals will be 0. It's your choice. If you want, you can, but never enter decimals in string values, in string data types. Now let's define the values for the gender. Let me take 0 for male and 1 for female. So sorry, female. Again, we'll have to check that here. Let me fix the alignment. All are in right, so I'll fix this in right also, so that it will look arranged and in a manner. Age is definitely nominal, gender is again nominal, and the salary is scale. Okay, now let's move towards the data view. Enter any data from your choice. I'm taking 54, 5, 46, 47, 48. That's it. In gender, I have defined 0, 1, 0, 1. So 0, 0, 0, 1, and 1. Salary, any salary you can take. 45,000, 54,000, 65,000, 50,000, and 90,000, let's say. So I have completed my data view. Now, how will we identify that whether we need to perform the parametric test or the non-parametric test? The simplest way is to go with the analysis, go with the descriptive analytics, statistics, and the explore. Here in explore, what we need to identify that on which variable. Definitely the dependent variable here is the salary. The salary is the dependent variable. Gender and age is independent variable. You cannot say that you can control the age or you can control the gender. Salary, this is under your control. So this is a dependent variable. Now move toward the plots and tick the histogram, and also the normality plots with test, so that we can check the normality of the data. Nothing in options, just tick the plots and okay. Now here in the output sheet, you will see a histogram, and you can identify your data from the histogram also. You can read. Here is a normal QQ plot of the salary. So the normal QQ plot of salary is here, and we can see a trend line in between of the plot. So in this normal distributed plot, we can see from here only we will observe, or we can understand that whether the data is normally distributed or it is skewed. You can see the dotted dots here. near the trend line. So always remember, if the dots are following the trend line and they are like gathering around the trend line, not scattered from the trend line, then the data is normally distributed. So the dots more close to the trend line, more data is normally distributed. If the dots are scattered from the trend line, they are far from the trend line, then definitely our data is skewed. And for the normally distributed data, we will perform a parametric, and for the skewed distribution, we will perform the non-parametric. So here we can see our data is skewed. It is not near the trend line, it is scattered from the trend line. So from here we will go to analyze. Now we know which test we need to perform. This is the list of our parametric test. In compare means all tests are parametric test. We have to perform non-parametric test. Now let me tell you, there are only one variable that is dependent. Rest two are independent variables. So how we like understand, or how we recognize which test in all those non-parametric tests need to perform on this data set? How will you understand? For the same, we will go to the word. Now here I have created a table for you guys, and you can say if the data is one sample, means if the data is one variable, then if data is normally distributed, parametric, and skewed distributed, non-parametric. We remember this: normal to parametric, skewed to non-parametric. One variable and non-parametric. That what the case was here. That was the case was here. The data was skewed and one variable is there. So we will go with the non-parametric and Wilcoxon test for one sample. Same, if there is correlation between two variables, we need to check the correlation. We will go to P Pearson or Spearman correlation. So I'm putting it here in the full screen mode. Just you guys can take a screenshot of it, take a snap, and save it for the future use. Again, two dependent variable, then which parametric and which non-parametric. More than two dependent variable, then which parametric and which non-parametric. If two independent, then which parametric test and which non-parametric test. If more than two independent, then which parametric and which non-parametric. So here is the detailed list of which test we need to perform on which type of data. Now move forward. So here we have one dependent variable, that is salary. So we'll go to analyze, non-parametric test, and one sample. Click, go to the setting and check the fields here the salary is there. So we will move the salary. Oh, I'm so sorry, we will move the salary here because this is the test field, and we will run. Now we can see here what are the null hypothesis for one sample t-test and what are the significance values, and also the decisions. We can see the null hypothesis is categories of the A's occur with the equal probabilities, and do we need to retain or do we need to continue with our null hypothesis? So the significant value is 1. Definitely we need to retain. As we all know that significant value, if less than 0.05, then only we will accept our null hypothesis. Otherwise we will accept our alternate hypothesis. So here is the sample how identify which test need to perform on which type of data set by checking the exploration of the data and the distribution of the data. Thanks for watching. See you in the next video. That will be of non-parametric again, but which type of test need to perform on this type of data. Thanks for watching.